Hello viewers, in today's class we are going to discuss yet another important problem from coordinate geometry, right? So here we are taking the concept of length of the chord intercepted by the ellipse x square over a square plus y square over b square is equal to 1 on the line y is equal to mx, right? And corresponding to this topic, we are going to solve this problem, that is find the length of the chord intercepted by this ellipse x square over 9 plus y square over 4 is equal to 1 on the line y is equal to 2x, right? So now let us see what we have to do, right? So here we have the coordinate axis, and this is x-axis and this is y-axis, right? And here we are going to draw a rough sketch of this problem, and let us take the ellipse like this, right? So this is the ellipse, and okay, so this is the ellipse whose equation is x square over a square plus y square over b square is equal to 1, right? And let us take the line y is equal to mx, and we know that this line y is equal to mx is the line which passes through the origin, right? So now if we draw the line like this, then we see that this line, that is y is equal to mx, it cuts the ellipse at 2 points, right? So these are the 2 points, and let us say this point is a and this point is b, right? And we have to find the length of this chord, right? So we have to find the length of this chord AB. Okay, so now here we have an ellipse whose general equation is x square over a square plus y square over b square equal to 1, and we have the line y is equal to mx. Now this line cuts this ellipse at 2 points, that is a and b. This line can also be drawn like this, and here for simplicity we are taking the line like this. So we have the 2 points a and b as point of intersection, right? And we have to find the length of this chord. Okay, so now here when we have the general equations of ellipse and the line, then we can derive a general formula for the length of this chord AB, and in this video we are not going to derive that formula, right? So here we are going to use the direct formula, and the formula, it reads like this, that is the length of this chord AB is equal to 2AB times square root of 1 plus m square over a square m square plus b square, right? So this is our formula to find out the length of this chord AB, right? So here we need to know the value of a, b and m, right? So here the equations of the ellipse are given as x square over 9, which can be written as 3 square, and here we have y square over 2 square, which is 4, is equal to 1, and here we have the equation of line as y is equal to 2x, right? And if we compare these two equations, we get a square is equal to 9, that is 3 square, and b square is equal to 4, which is 2 square, right? So the value of A is 3 and the value of B is 2, right? And here if we compare these two equations, then the value of M is 2, right? So here we have 2, right? So here A is the length of the semi-major axis and B is the length of semi-minor axis, and M is the slope of this line, right? So now we can simply substitute these values in this result to get the length of this chord AB, right? So now AB is equal to 2 times A and B are 3 and 2. So here we have 3 times 2, and then we have 1 plus M square, which is 2 square, and here we have A square is 9 and M square, which is 2 square, that is 4, plus B square is 4, right? So now AB is equal to, this is 4 3s are 12, and here we have 4 square, 2 square is 4, 4 plus 1 5, and here we have 36 plus 4, that is 40, right? And this is 12 times, and here we have 1 over 8, right? So the length of the chord is AB, which is equal to 12 over square root of 8, which is 12 over 2 root 2, and this is 6 over square root of 2, right? And we can rationalize the numerator. So here we have AB is equal to 6 times root 2 over root 2 times root 2, and this is 6 root 2 over 2, and that is 3 root 2, right? So the length of this chord AB, which is intercepted between this ellipse and the line y is equal to mx or 2x, is given by AB is equal to 3 root 2 units, right? So this is how we find out the length of the chord intercepted by this ellipse on this line y is equal to 2x, right? So viewers, here we have applied the direct formula to get the value of AB, and in our next video we'll see how we can derive this expression.